For this experiment, I have water, salt, 2 pencils, and they have been sharpened on each end of the pencil. So both sides have the graphite exposed. Graphite is a pretty good conductor of electricity, and wood is not a very good conductor of electricity, so I'm hoping that electricity will flow through from end to end. I have 2 wires, and at the end you can see they look like little baby crocodiles, and you may have seen these if you've ever seen a jumper cable, like for a car. If a car dies, if its battery dies, you need to hook up this end to another car from battery to recharge that battery. Speaking of batteries, I have a battery. This is a 9-volt battery. I have a piece of cardboard. The only thing this is for is so that I can make the pencils float and not touch the bottom of the beaker, and then I have a beaker that all of this will be happening in. So let's give it a shot. So I've got some water. I have it on the warm side. I did not measure with a thermometer, but I can tell you that it is warm to the touch, but not hot. And I'm going to add some salt. I'm not measuring, but about 3 tablespoons-ish. And I have a popsicle stick just to stir. Stirring it until the salt dissolves or until I can't see it anymore. Now you might want to think about, I'm trying to split water, but there is a reason that I added salt. You might want to think about why that might be. Maybe you have a family member that adds salt to a pot of water before they boil it. The theory is that it might make the pot of water boil faster. In this case, we're adding it because it will basically help the water conduct electricity faster and better, so that hopefully we'll get a reaction a little quicker here. So I have my cardboard on top. I've got my 2 pencils. I'm going to put them down far enough into the water so that they're not touching the bottom. Okay, now I'm ready for my battery. So this is actually this is the positive side. Looks like that, and negative side isn't labeled, but it's a little bit different. And so I'm going to hook the red wire up to the positive side. Doesn't matter the color, but just so that you can keep track of it. And I'm going to hook that up to this end of the graphite. Make sure there's a good connection. And just to show you that there's no funny business going on here, let's take a look at the pencils before we add any electricity. So make some observations about what you see before. All right, and now I'm taking the black wire, making sure I have a good connection, and I am ready to complete the circuit. Here we go. Ready, and let's see what happens. So it's a little hard to see, but perhaps you can notice that the pencil on the right has smaller bubbles coming at a much faster rate, and the pencil on the right has some larger bubbles. They're actually coming out at a slower rate. Might be hard to hear, but I can hear bubbling. If I put my hand to the beaker, the water is still warm, not overwhelmingly hot. I can't smell anything. And just to see what happens when we remove the electricity or stop the circuit. Let's see. So I'm about to unclip up here. So 3, 2, 1, unclip. And 3, 2, 1, my circuit is back. You can see very quickly those bubbles return. What could be going on here? What is, clearly there's gas, but what is this gas?